Measurements. When we talk about measurements, what we're talking about is the comparison of an unknown to some standard. Um, a standard unit is simply one that is fixed and reproducible, and it is basically for the reason of for comparison. Now, the International System of Units, or the SI system, has 7 fundamental units. Okay, in the British system, or the system that we're used to in the United States, if you think about distance, there's inches, miles, feet, yards, fathoms, furlongs. There's all these different units. Well, the International System, or the SI system of unit, has 7 fundamental units, and they are for length. We have the meter. Again, the meter is defined on the basis of the distance that light can travel in a vacuum in some fraction of a second. For mass, we have the kilogram. And there's something a little bit special here about the kilogram. That is the only unit that has a prefix on it. And the reason why is the gram is so small you really can't tell the difference between 1 and 2 grams in your hand. Whereas a kilogram, or 1,000 grams, is hefty enough that you can tell the difference. Also, the definition of a kilogram is different than all of the rest because it is the only one that isn't independent of a physical thing. We actually have a block that weighs a kilogram, and every couple of years we have to take it back to Paris to the International Bureau of Standards and make sure that the United States has a kilogram that is exactly the same as the international standard. Everything else is defined in terms of something that, if we just blew the world up, we could still define and figure out what those units were. For time, the SI fundamental unit is the second, something we're used to. For electric current, we have the ampere. Okay? For temperature, now this one might mess with you a little bit. For temp, or temperature, we have the Kelvin. And we use the Kelvin scale. It's not the Celsius scale, it is the Kelvin scale. For amount, we have the fundamental unit of the mole. And the mole is actually defined in terms of the exact number of carbon atoms in 12 grams of carbon-12. 1, 2, 3, 4, 5, 6. One more. For luminous intensity, we have the candela. And if you'll notice, if you go buy a flashlight, some of these really, $30, $40, $100 flashlights will have like 250 lumens and everything. It's not the same unit. The luminous intensity is the fundamental unit for that is the candela. Now, if you're in physical science, these can be found along with their definitions on page A1, which is the first page of the appendices at the back. And it's the very first yellow page at the back of your textbook. Okay, now we also want to think about the way that we describe a measurement. When we start looking at the units and the measurements and things, basically we're using our power of observation, and there's 2 different types of observations that we tend to make. One is a qualitative observation, and the other is a quantitative observation. Qualitative is simply a quality. That's a nice picture. There's a lot of people in this room, that type of thing. Whereas a quantitative observation includes a number and a unit, which in effect is a measurement. Okay? A measurement has to include a number and a unit. Okay? Now, getting into the metric system. One of the reasons that people will actually make the statement that the metric system is easier than the English system, which most people kind of roll their eyes if you're from the United States. Of course it's not as simple. Well, actually, it is more simple in that whenever we're talking about, let's say, distance or length, the unit is a meter. It's not a foot, an inch, a yard. It's not any of 27 units. It's a meter. For volume, we're looking at a liter. For mass, we're looking at a gram. Now, we can really and truly, that's all we would have to have, except we're really bad about writing numbers. If you start having a bunch of zeros, 0.000000001, you're going to miscount. So instead of using all those zeros, what we do is we use prefixes. And a lot of times people get really messed up on the prefixes because they're trying to remember all of them, and you don't have to. You only need the ones you use. Okay, so let me put a new page on this and scroll it up a little bit here so that we can look at some of the prefixes we use and the easiest way that I can think of converting between them. Okay, so I'm going to draw just a straight line. It's not incredibly straight, but it's about as good as it's going to get. Okay, on this side, I'm going to make this my big side. On this side, it's my small side. Okay, and this may seem a little simple, but right there in the middle, stick with me, I'm going to put 10 to the 0. And I want you to pay attention to the exponent here. Okay, way over here, I'm going to put 10 to the minus 6, 10 to the minus 3, 10 to the third, and then finally 10 to the 6. Now, say it with me. If we look at these exponents, we've got minus 6, minus 3, 0, 3, 6. Now I'm going to mess that pattern up just a little bit. Right here, I'm going to go ahead and add 10 to the minus 2. Okay? So there's my pattern. Minus 6, minus 3, 0, 3, 6, and then go ahead and put the minus 2 in there. Now, before we get into the prefixes, let's just look at this line for a minute. If I go from this one to that one, that is 3 places. If I go from that one back, that is still 3 places. If I go from minus 3 to minus 2, that's just 1 place. But if I were to go from minus 6 all the way over here to minus 2, that would be 4 places, and so forth. If I went all the way from minus 3 all the way over here to positive 3, that would be 6 places. Okay, if I went from minus 2 to 3, that would be 5 places. Okay, so if we just remember this number line and can designate how many steps there are between these numbers, you've got half the battle on metric conversions done right there. Okay? So I'm going to get a clean number line. There it is. Isn't that pretty? And I'm going to add our prefixes to it. Now, these you will have to memorize. Here at 10 to the minus 6, things really small, we have to use a microscope. So the minus 6 prefix is micro. And the symbol that we use for micro is a Greek letter mu, which is basically the letter U with a long front tail. Here at minus 3, we have milli, which is a lowercase m. At 10 to the minus 2, that is centa, which is a lowercase c. Now here at 10 to the 0, that is our base unit. So that's either going to be gram, meter, liter, second, byte, whatever you're using, mole, whatever your base unit is, that's at 10 to the 0. 10 to the third, that is kilo, which is a lowercase k. And at 10 to the 6, the prefix that matches that is mega, and that is a capital M. Okay. Now, just very quickly, can you tell me which is bigger? A milli something or a kilo something? Well, since this is a big side, the kilo something is bigger. Okay? Which is bigger, a milli or a micro? Well, in this case, milli is the larger. Okay, so if you look at that, if you can figure out which unit is bigger, okay, or on this number line is bigger unit, then there's a little system. And the thing to remember is the big guy is number 1. Okay? Now, in doing this, all of this, what we're trying to do is set ourselves up so that we can do metric conversions easily. Okay? So right there, I want to stop, and I'll do the actual conversions here on the very next one. But at this point, I want you to practice doing this number line and putting these metric prefixes where they belong. That's going to be a big part of this. Okay, this is part 1. I'll do another video to finish this up.